over on the blitz. He's open. Colasar. He'll go the distance. They won't catch him.
Hello, I'm Larry Adderley. Today I want to tell you about the design and servicing of Renault and Jeep wet sleeve engines, and about football. What do the two have in common? Probably more than you realize. Watch. You're all familiar with action scenes like this. Americans spend countless hours glued to the tube watching their favorite games. But what is the great attraction, this fascination that can turn so many of us on? If you're a true fan like me, you already know. You know the special excitement of watching the best in the business compete head-to-head. That inner satisfaction in seeing a group of individuals excel in a smoothly coordinated team effort, each player executing his particular tasks to the very best of his ability. Satisfaction, pride, a competitive spirit, striving to be the best you can possibly be. That's what it's all about. And that's what your job is all about, too. Stop and think. Is your job all that different? Outwardly, perhaps, but you, too, are a specialist at what you do. In servicing today's high-tech vehicles, your playbook is every bit as complex and demanding as the one Bo Schembechler uses for his Michigan Wolverines, or Tom Landry uses for his Dallas Cowboys. Even more so. So you have to know the plays. And this video disc is one of your game films, showing you how to execute properly when tackling a wet sleeve engine. On this side, our first half, we'll introduce wet sleeve engines from a design standpoint, tell you how they differ from conventional engines, how they simplify servicing. Then we'll get right inside, use drawings to show you what they look like internally, and cover how it all fits together. Next, we'll talk about special characteristics of wet sleeve engines. Piston liner, liner protrusion, piston liner kits, things you need to understand to do a proper job of servicing. Finally, we'll get to our game plan, review a few basic service procedures unique to wet sleeve engines, head removal, liner clamp usage, protrusion measurement, and piston to rod assembly and installation. On the other side of this disc, our second half, we'll take you step by step through removal and reinstallation of a piston and liner assembly. So now, let's kick off our discussion. This is the heart of the wet sleeve idea, the piston liner, and it's the key to important owner benefits. To understand why, let's review basic engine approaches. Start with your familiar engine block, or monoblock as it's sometimes called. This basic design has been used in passenger cars and light trucks almost since the invention of the automobile. Here we see the traditional approach, which you find in most engines even today. That is, the piston rings contact and seal against cylinders which were bored directly into the block. If the cylinders wear beyond service specifications, you can replace the block or rebore and install oversized pistons. Now let's look at the wet sleeve design. The important point to note here is that we've added a sleeve, also called a liner, to form a cylinder for the piston to operate in. This is done at the factory when the engine is built. Here, the piston and rings contact the liner, not the cylinder walls, which were bored directly in the block. The liner takes all the wear and tear, not the block. Another key difference is in the cooling system. In the conventional monoblock engine, the coolant does not always completely surround the cylinder walls. With our wet sleeve design, the coolant surrounds and contacts nearly the entire outside surface of the liner and provides maximum cooling effect right where it's needed most. In fact, that's why we call this a wet sleeve design. The coolant contacts the liner directly. But the biggest advantage of the wet sleeve design is in ease of servicing. Let's assume we have a conventional monoblock engine with one or more cylinders severely worn, tapered, or out of round. That compression's way below par. Or just as likely, old Bessie's starting to burn oil. If the owner's lucky, he may get away with having new rings installed. But the trouble could be severely worn cylinder walls. Reboring and going to oversize may help, but not always. If the wear is too severe, the owner may be facing replacement of the block. Now you're talking serious money. In fact, on many older cars, such an ailment is considered terminal. Now look at our wet sleeve design. A different story altogether. Here we have replaceable cylinder liners. As we mentioned, the liner takes all the wear and tear. If the liner is worn or damaged, you don't have to replace the block. You simply replace pistons and liners. This means a lot less work for you and big savings for the owner. So the liner is the key to the wet sleeve design. In fact, we use the terms liner and sleeve interchangeably. The liner is the sleeve, and it really does the job. It's made of cast iron and is extremely hard. So when we install a set of these in a block, we get excellent wear characteristics. And we're then free to use a lightweight block design. Specifically, we feature a cast aluminum block in all Type A 1.6-liter engines and in all Type J engines, both the 2.1-liter diesel and the 2.2-liter gasoline versions. Because of the sleeves, we were also able to go to a trimmed-down, thin wall construction in our Type C 1.4-liter cast iron engine blocks. In all cases, the liners allowed us to use weight-efficient engine blocks. And thanks to the liner, we don't have to sacrifice durability in the aluminum versions. True, cast iron is hard, much harder than aluminum. But in an engine, this hardness is only important in wearing surfaces, right where the piston rings contact the cylinder walls. In the rest of the cylinder block, hardness isn't all that important. So we still benefit from the good wear characteristics of cast iron where we need it, plus the advantage of a lightweight block. The best of both worlds. The liner, then, is a positive feature, giving us ease of servicing, an efficient cooling arrangement, the advantages of a lightweight block, and good wear characteristics. But time out. Let's catch our breath and review what we've covered so far. Let's see how smart you've become watching all this. Check yourself out with this review. I trust you did well. I trust, too, you understand now what the wet sleeve design is all about. But how does this wet sleeve design affect you where you operate? How much parts difference is there, for example, between a wet sleeve and a monoblock engine? Let's see. Here we have the two types of engines. On the left, a Type C engine with wet sleeve construction. On the right, a conventional monoblock Type F engine. The good news from your standpoint is that the two types of engines are very much alike. They still have the same types of crankshafts in both engines. Both have camshafts, either the overhead or pushrod type, and basically the same type of pistons. The only real difference is that this one has liners instead of cylinders bored directly into the block. So you're in very familiar territory. It's not as though we've changed the game on you, asked you to learn a whole new set of rules. We're introducing a few new plays, sure, but plays no more difficult, no trickier than what you're used to. And that's what the rest of this session is all about. Familiarizing you with the new plays, bringing out some of the fine points, helping you understand your job. But before anybody gets their hands dirty, let's first take a closer look at our liner, its sealing, and how it all fits together. This is the cylinder block of a Type C 1.4-liter engine. There are a few points to note here. For example, the sleeves, at casual glance, seem to set flush with the top of the block. Actually, they must protrude slightly above the cylinder block gasket surface, and the amount of this protrusion is extremely critical to proper engine operation. When the cylinder head is installed, it actually compresses against the top of the head gasket and then the liner. It doesn't just rest on the block. This assures that the liners stay in place and remain properly seated. Down inside the engine block, the liners rest on specially machined shoulders, along with either an O-ring or a gasket to prevent coolant leaks. If the protrusion isn't right, or if the seal or gasket is damaged in some way, coolant can leak into the oil pan, as shown here. Another point of possible leakage is at the top of the liner into the combustion chamber. Here, the problem could be a blown head gasket caused by improper protrusion of the liner above the block surface. I think you can see now why precise liner protrusion is absolutely essential. In our A, C, and J engines, the liner actually rests metal to metal down in the cylinder shoulder. The O-ring seal is located here and doesn't affect protrusion. In some of our engines, such as the 810 used in some Le Car models, the seal is also a shim selected to control protrusion. We use different tolerances and procedures for these engines. However, no matter what type of Renault or Jeep wet sleeve engine you're working with, there are three types of dimensional relationships to monitor and control. The first one is the minimum and maximum tolerances for individual liner protrusion. The exact specs depend on engine type. Second, we need to maintain a certain standard of uniformity. We don't want too much protrusion variance between adjacent liners. Otherwise, when we torque down the head, we won't get uniform contact on all four sleeves, even though all of the liners may be within their individual protrusion specifications. Third, it makes a difference how we arrange our highs and lows. Let me show you what happens with random liner placement. We've exaggerated the amount of protrusion here just to make our point obvious. Assume that these liners are individually within protrusion and variance specifications. Now suppose this straight line represents the bearing surface of our cylinder head. When you torque it down, you've got gaps on two liners. This means there you've lost an effective seal. Now see what happens when we simply arrange the four liners in sequence, going from the lowest to highest. We call this arrangement the step method. This assures an even hold-down pressure is being applied to all four liners. But liner protrusion is only one area to be careful about in wet sleeve engines. There are others. For example, replacement liners are supplied in a kit form complete with matching pistons. If you have to replace a piston for whatever reason, you also have to replace its liner. In fact, you have to replace all four pistons and liners as a set. Here are the parts just as you find them in the carton. All four of these liners and pistons are precision machined in sets at the factory, automatically giving us the proper operating clearance between liner and piston. The same is true of liners and pistons installed in the engine as original equipment. Therefore, you must match mark them as you take them out of the carton or out of the engine. Liner A with piston A, liner B with piston B, and so on. Check your workshop manual for reference. You can't use just any liner in the kit with any other piston in the same kit. The pistons are also matched to each other at the factory for weight to assure ideal balance. So always use the full set as it comes in the carton. If you don't, it's a definite infraction. If you try to get by with just installing one piston trying to get ahead of the game, you're violating a basic rule and your customer will suffer the penalty. Do you have all that? There's nothing complicated about it any more than blocking and tackling are complicated. Just remember your basics. So why don't we take another time out and test your memory? Now that wasn't too difficult. None of this is, if you simply take it step by step. And on the reverse side of this disc, we'll get into step-by-step removal and reinstallation. But first, I'd like to call special attention to a couple of key procedures you have to be careful with when servicing wet sleeve engines. The first is that of cylinder head removal. The natural tendency in removing a head is to simply unbolt it and lift it right off. That's the obvious way, right? But that'll cost you 5 yards, because once you do it on a wet sleeve engine, you'll probably wish you hadn't. What happens here is that the liners tend to lift up with the head. This can cause real problems. Almost invariably, lifting the liners even slightly allows debris to fall down onto the cylinder shoulders and get trapped down under the liner. Now there's no way the protrusion is going to be correct. As a result, coolant can leak into the oil pan, as shown here. You have to go in and remove, remeasure, reseal, and reinstall every liner. To prevent this, you must use a special technique called shearing before removing the head. We get into the procedure in more detail on the other side of this disc. For now, we'll review the high points. You'll want to check your workshop manual before you start. First, you have to locate the pivot bolt. This bolt corresponds to the location of a dowel which aligns the head to the block. Every wet sleeve engine has one, but the location varies by engine. Once you know which one it is, you remove all other bolts. You only loosen the pivot bolt about half a turn. Then, using that bolt as a pivot, swivel the head to break the seal between head and liners. Now you can remove the pivot bolt and lift the head off the block without raising the liners. At this point, we should cover liner clamping. Keep in mind that there's nothing to hold those liners in place once the head has been removed. We'll cover liner clamping again on the other side of this disc, but for now, let's highlight the procedure because it is important. On the 1.4-liter Type C engine, we use liner clamp MOT 521.01. Other engines use different liner clamp tools. The point is, a clamp must be used as soon as the head comes off. As you can see, the clamp bolts down on a block to hold the liners in place. This allows you to rotate the crankshaft without fear of the pistons raising the liners and breaking the seal between the liner and block shoulder. Another procedure that's different from that of many other engines is piston-to-rod assembly. And again, there are certain special tools required for the procedure. There's also a difference in procedure according to the engine type, so be sure to consult your workshop manual. We'll use a Type C 1.4-liter engine for our example. In this engine, the pistons are marked with an arrow on their heads which must point toward the flywheel when installed in the engine. This recess on one side of the piston pin boss is designed to fit on a thrust collar. This collar is part of the MOT 574.11 special toolkit used for piston installation. You should also note that each connecting rod has a cylinder number on it, which is made during engine disassembly. Check your workshop manual for details. With this in mind, let's take a look at the procedure for installing a piston onto a connecting rod. First, heat the pin end of the rod using a hot plate, not a torch, which heats unevenly. It should get hot enough to melt a piece of solder with a melting point of 480 degrees Fahrenheit or 250 degrees centigrade. A 50-50 solid core solder works best. Then, mount the replacement wrist pin loosely onto the proper size mandrel from the MOT 547.11 toolkit. But do not tighten. Lightly lubricate both. Select the proper size thrust collar for the engine you're working on. Place the thrust collar on the support base. Then clamp the piston onto the support base so that the piston's recess facing rests on the thrust collar. Insert the mandrel and pin partway into the piston's pin boss. Next, remove the connecting rod from the hot plate and quickly put the connecting rod into the piston with one hand so that the piston arrow and rod markings are lined up correctly. With the other hand, quickly press down on the mandrel until the guide butts up against the bottom of the support piece. After a few seconds, remove the rod piston assembly from the support base. Unscrew the guide and remove the mandrel. Rotate the rod back and forth in the piston to check free movement and make sure the pin stays in place. And that's all there is to installing the rod to the pistons. Now, what about these? The piston rings. First, you should note that these rings are pre-gapped. You should never file them. You simply install the oil scraper ring, the compression ring, and the combustion ring in that order. make sure that the compression or middle ring top marked O or top faces upward toward the top of the piston. Mount rings so that the three end gaps are equally spaced 120 degrees apart. After assembly, lubricate the pistons with engine oil. One final note, the oil ring for Type C engine looks like it's too large. Don't worry, it's designed that way. As long as the ends are butted together when you install the ring into the liner, it'll work just fine. So now you're familiar with the basic game plan, and you know the special points, the tricks of the trade to watch out for. You're ready now to get down to details. See what complete piston liner removal and reinstallation are all about. But that's covered on the other side of this disc. Now it's halftime. A good time for another review.